Alright, so today is going to be our final day of solving quadratic equation word problems where we're going to be using what's called the vertical motion formula. So this is a real-life application of basically acceleration due to gravity on our planet. So one of the things we're always going to see if we're talking about Earth, and we'll have to revisit this in a couple weeks, looking at other planets where the force of gravity is going to be a little bit different. But the coefficient here, if we're talking about feet, is always going to be negative 16. If it's meters, which we're not going to really take a look at, but you may see it somewhere in meters, it'll be 4 9/10 usually. So this is the height of a ball dropped from the top of a building can be modeled by the following. So again, this is telling us, and if I was doing this in class, I'd throw a marker up in the air and we'd make a little table and we'd have a big discussion about it. But since you can't see me, that's not really going to be very helpful. But that's going to tell us how fast, how far something is going to fall after t seconds. So just forgetting about this part for now, just kind of as a sidebar here, right? So if t is equal to 1, negative 16t squared is negative 16. If t is equal to 2, negative 16t squared is negative 16 times 4 is negative 64. If t is equal to 3, it's negative 16 times 9, which is negative 144. And if t is equal to 4, it's negative 16 times 16 is negative 256. Basically, this is telling us how far any object, right? Obviously neglecting, things like a feather or something that would be really subject to wind resistance, how far an object would fall after that many seconds, right? So the first second, and you could model this if you wanted to in your house, the first second something would fall 16 feet. After the second, with the first and 2 seconds combined, it will have fallen 64 feet. After 3 seconds, 144, and after 4 seconds, 256. So you can clearly see that there's acceleration. That's the acceleration due to gravity. All right, so let's get to our actual problem here. So it says, how many seconds will it take the ball to hit the ground? Well, one way we can do it is we can put it in our calculator and we can make a table. I'm going to have t, and I'm going to have h of t. H of t means the height of the object is a function of time. So instead of f of t, which we could use, we use h because h is the height. So after 0 seconds, and again, I'm doing this by hand, but you can pull this right from your calculator. Just remember that we're not putting in t, we're putting in x. I know we had a problem with one of the homework assignments that had a different variable. You guys used the letter key on your calculator and it gave you a linear equation. So make sure we're using x as the variable. So at 0, it's going to be 144, right? At 0 seconds, I haven't dropped the object yet. At a time of 1, if I substitute that in there, it's going to give me 128. If I substitute in a 2, it's going to give me, I believe, 80. And if I substitute in a 3, it's going to give me 0. So the question is saying, how many seconds will it take the ball to hit the ground? Well, after 3 seconds, the height is 0. Well, that means it hit the ground, right? If the height of an object is 0, it's on the ground. So the answer would be 3 seconds. And that's really not going to be our preferred way of doing this, right? We spent weeks and weeks on quadratic equations for a reason. So if we're going to solve this equation, we're going to say, I want the height to be 0. So I'm going to say, how can I solve the equation 0 equals negative 16t squared plus 144? Well, I don't really want the coefficient to be negative 16. I could factor it out, but let's divide both sides by negative 16. I'm going to do this really for most of them. If I do that, I get 0 equals t squared minus 9. Hopefully we identify this as a difference of squares. Now I've got t plus 3 is 0. And I know I encourage you guys to solve the equations, but I'm a little short on space here. Now, t equals negative 3 is that doesn't exist, right? So this one's going to get rejected. Now, if you look at the graph, the graph is going to show it hits the x-axis at 3 and negative 3, but we're really only looking, if you're looking at a graph of this, our graph's going to look in the first quadrant like that. We only care about the first quadrant. We don't care about negative 3 seconds because that didn't happen. So if you're looking at a graph, you would have 3 seconds. But really, we want to try to do this again. We spent so long on quadratics, we want to do this using the quadratic equation. And again, we can confirm that our answer should be 3 seconds. All right, so the vertical motion formula. So as far as notes, now this isn't something that you're going to have to memorize, right? If this shows up in the regions, they will give you all the components. But we really should understand the formula. So it says it can be used to model the height of an object after t seconds. Okay, So this, and these are going to be our variables. That's our time. V is what's called the initial upward velocity. So in the first example that we looked at, there was no upward velocity, right? I was dropping an object. Now, if I'm dropping an object, there's going to be no x term, right, or no t term, because we're not throwing it up in the air, we're just dropping it. But in most cases, or at least the three that we're going to look at here, we're going to be throwing it up in the air and kind of waiting for it to come down. And then the initial height here is our constant. All right, so we're just really filling in this information. So I'm going to say, now it says an object is 240 feet off the ground, so like top of a building. It's launched upward at a rate of 32 feet per second. When will it hit the ground? So our height, as a function of time, is equal to negative 16t squared. Now vt is our initial upward velocity, which is 32, so plus 32t. And the initial height of the object, which is our constant, is 240. So that's going to be my equation. Now we said one thing we can do is we can check out the table. Right, and again, this is not really the preferred way of doing it, but it'll work. So if I make a table here with t and h, right, height is a function of time. At 0, I'm at 240. After 1 second, I'm at 224. After 2 seconds, I'm at 192. I'm at 240, sorry. So what happens here, right? We started at 240, right? And then the object actually went up. So let me fix this. That should be 252. So again, guys, you can pull this right from your calculator. So that should be 252. And then at 3, you should be at 192. And then 112. And finally down here at 0. And again, not the preferred way of doing it. We would really prefer to do this using the quadratic. But it works, right? When will it hit the ground? So it's going to hit the ground in 5 seconds. Well, what can we do if we want to do it as a quadratic? Well, first of all, we want the height to be 0. And we realize that all of these coefficients here and the constant are multiples of 16. So I'm going to divide by negative 16. Right? If you don't divide by negative 16, you're going to have a problem because we don't really do too well factoring negative x squared. So this is going to give me 0 equals t squared minus 2t minus 15. And we'll take a fresh page for that. So let's see what this looks like. So I get t minus 5 times t plus 3. Now we're going to split it. We're going to solve each of the equations. So one of them will be t equals 5 seconds, which we already saw from our table. And the other one's going to get rejected. And again, yeah, we could look at this on the graph if we wanted to. And yeah, at negative 3, it's going to touch the x-axis. Right? So if we look at this in the first quadrant only, it's going to look something like that. Right? Where this is going to be 5 seconds, which makes sense. Right? You're throwing something, you're starting it here. You're throwing it up in the air. It's going up very briefly, and then it's coming down. Right? You didn't throw it up too hard. Then if we looked at all 4 quadrants, right, all 4 quadrants is actually going to look like that, which is kind of meaningless. Right, we don't care about negative 3 seconds and negative 4 seconds. Right? We just care about this part of the graph. So if you're doing this, and we talked about ways to change your window, your x min and your y min would be 0 if you wanted to see just the first quadrant. So again, this table here is modeling what's happening. Right? We're at 240, we throw it up. For 1 second, it goes up. That's our vertex, which we'll talk about when we revisit this in a few weeks. And then it starts, right, gravity starts to pull it down faster and faster until at second number 5, it's going to exactly hit the ground. So again, our procedure here, there's really 3 ways we can do it. Right? We can do it here. Right? We can use the table from our graphing calculator, which we should be doing anyway to check. Preferred method is going to be use our quadratic equation, divide by negative 16, or in some cases a different common factor. Or we could also use the graph, and we can actually look at the x-axis on the graph. Now, I don't think I'm going to do this one, but if we were going to do this one just to kind of get you started here, I've got h0, which is going to be our height. I've got negative 16t squared. My upward velocity is 8. And my initial height, which is my constant, is 120. So again, I'm not going to do this one because we're getting a little long on time, but what I was saying a minute ago, I can't divide by negative 16 here. I could if I want to deal with the coefficient of t at half. So here we divide by negative 8. So just in case we do see this at some point, now I've got t squared minus t minus 15. So I'm going to use 5-step method. And this is actually a really easy one to do using 5-step method. For a lot of you guys seem to use trial and error, we can use trial and error as well. All right, so this would be a good thing to actually do now try on your own. Obviously, you can always go back and, rewatch the video. But I did say with the, when I gave you the assignment that you are really going to have, need some notes in order to do the homework. All right, so let's take a look at this. Be a good idea to pause it. And now we'll come back and go over it, right? So here's my function again. So v is my initial upward velocity, which in this case is 16 feet per second. And h is my height. That's my constant. That's where we start at. So I'm going to have 0, right? We want to know when it's going to hit the ground, as always. So 0 is equal to negative 16t squared plus our initial upward velocity, which is 16t, plus my constant, which is 320. All right, and let's do the same thing. All right, let's put this on the table first, and then we'll come back to it. Right, so I've got my time in seconds, and I've got my height, which is a function of time. And at time 0, my height is 320. At time 1, my height is also 320. Now, if you look at this in your graph, you're going to see it briefly go up and then come down. My vertex is actually going to be time of half, which again, when we revisit this, we'll talk about that in a lot more detail. It doesn't make sense that it starts at 320 and after a full second it's back at 320. It's not stagnant in the air. It's going up for half a second, and then it's going down for half a second, and then of course it's continuing to go down. Right? So at time 2, we're going to be at 288. At time 3, and again, you guys really should all be putting this into your calculator so you can see it and not just taking my word for it. At 4, we're at 128, and at 5, we're at 0. So we would expect, when I solve this quadratic equation, now we get time 5, right? So let's do what we've been doing and divide everything by negative 16. So I've got t squared minus t minus 20. So this one should be a really easy one to factor. And t squared minus t minus 20 is going to factor as t minus 5, t plus 4. So I've got t minus 5 is equal to 0. I've got t plus 4 is equal to 0. So one of my solutions, as we kind of expected, is t is 5. And the other one is t is negative 4, which, again, we're going to say is rejected. Right? And again, if you want to go back and use that other method, you really should look at the graph in the first quadrant. So what are we going to see? We're going to see a very small uptick before it starts to come down. And if you look at this on your first quadrant, it's going to be 5. And again, if you expand this to your entire graph, not really a lot of worth in that, right? I don't care about whatever this is here. I don't care about any of these negative values. I just care about this part of the graph. So you'd want to make your x-min 0 and your y-min 0. But that's really not a preferred way of doing it, right? A real preferred way of doing it is by factoring. We said we can also kind of double check it by putting it in our calculator and then looking at the table. All right, guys, have a great weekend. Any questions about this whatsoever, just make sure you shoot me a message and I can get you the equations and then you should be able to solve them on your own.